understand that yesterday was a practice quiz, and today I'm going to be helping you understand what you need to make sure you know for the summative. Your summative is going to be making a poster. I'm holding this up because this is an example of a poster somebody made last year. You're going to be telling me about different proxy data on your poster. And then there's going to be one more layer of the summative. You're going to explain your poster to me. And the purpose of that is really just to make sure that you understand what you wrote on your poster and you didn't work too closely with a partner on making your poster. Okay? So the sequence of what's going to happen is today I'm going to explain things through lecture to you with a PowerPoint. Tomorrow you're going to make a poster. And Monday you're going to defend your poster to me. And then we'll be done with this unit and moving on.
So tomorrow we're going to do all that?
Tomorrow you're going to put together your poster, yeah.
All that?
Sure. If you're going for an A. This person tried for an A. I know they tried for an A because they did all 5 proxy datas. But they ended up only getting a B because they didn't explain them all deeply enough. Understand? You actually don't need a ton of writing because you're going to explain it to me. You just need a little bit of writing.
So why did I write the outline?
She was trying real hard for an A. She thought she needed to say everything on the paper. Okay? Okay. So what are we learning right now? Please turn to the person next to you and tell them, like, I'm going to lecture at you today. What am I going to talk about? What are we learning right now? Please turn and talk. Stuff is not a correct answer.
All right.
You see this? No. You said it. I get an A on this with my grade.
I don't know. I'm going to put it in the computer. You know. Yeah. I mean, your average would go up.
You are. I already told me what you said, bro.
Bella, can you get ready to write and put it on your phone?
For you.
Get ready to write? All right. Time's up. Marie, what's your guess as to what we're going to be learning about today? Awesome. How do we find out about the climate back then and the different ways we find out about it? Harmon, right now you're making a bad choice. Please make a different choice. Okay, so what we're learning about, Marie just told us. How we learn about past climate and the different ways we know about it. How are we learning about it today? How am I delivering that information to you?
Wait.
Does anyone know how we're doing class today?
Oh, we're taking notes.
You're taking notes from a lecture, yeah?
The whole class will take notes?
For the whole class. Get comfortable, my friend. And why are we learning this?
So we can prepare for it.
Oh, because we're
Okay,
here.
great. So short term, we're learning this so we can prepare for our test.
So we know what we need to put on our poster.
So you know what you need to put on your poster. Cassie and Emily, please choose a seat where you can write and not talk. And why are we learning about old climates in the first place?
So we can know
So we
what
know-
time it is today.
So we can understand the climate today, and more importantly, what's coming next, the future. Understand? Okay, cool. So you should all be ready to write. Abby was just getting out her notebook. I saw it in her eyes. DJ was turning around to grab his so he could write on it. Zach was getting out a pen or pencil. I can tell we're almost ready to go. So I want to show you first, before we get too carried away, the results from our little practice test yesterday. And I want to focus in on some of the questions that maybe we need to spend more time practicing. So when I look at the results of this test, 70% of you, that's 19 of you, got this first question correct. So I think most of you know that climate is the average temperature and precipitation year after year. So I'm probably going to go past that part of the presentation faster. Same thing, you know that climates are both decided by temperature and precipitation. That makes me super excited to know that you're mostly all getting that question right, because we talked a lot about how climate isn't just whether it's hot or cold, but it's about whether it's hot and dry or hot and wet. So it's temperature and precipitation that makes up the climate. But a lot of people, about half of you, got this question wrong. You thought that very old weather records were a way that we found out about past climates, ancient climates. And the reason that's wrong is because we're talking about climates that are older than people, older than the weather records that we have. So those are not a way we can find out about it, which is why we're talking about the other things, which are called proxy data. This question was about carbonates, and many people got it wrong, which is understandable because you probably needed to be on the field trip in order to know this. And I wanted to point it out real quick today that if you weren't on the field trip and you're still trying for an A on your summative, you're going to need to pay close attention today because I'm going to review a few things from the field trip. And if you weren't there, this will be your opportunity to hear about it. So other questions that we probably need to talk about are isotopes. This is a question a lot of people got wrong. So today when I'm talking to you about isotopes, I would expect you to be honing in on that information and maybe even asking questions about it as I am presenting. The difference between carbon-12 and carbon-13. So this connects to that idea of isotopes. Carbon-12 and carbon-13 are two different isotopes. They have different mass. And a lot of people thought that the number of protons is what would be different, but that would make them not carbon. Towards the end of the exam, we did a lot better. People were doing a good job of answering those questions. And this question, what is a proxy? So that's kind of the moral of our presentation today. By the time we're done, you should know for sure what a proxy is. I'll probably say it 5 or 6 times. So now we know that isotopes and proxies are some of the things we need to pay extra attention to today, because those are things we didn't do as well on yesterday. So I'm going to go ahead and transition into the presentation. And I want to remind you that you're going to be taking notes today. I am not going to ask you to write down every single thing you see on every single slide. That is not a good note-taking strategy. A good note-taking strategy is to write down main ideas, things you hear me say, maybe some important vocabulary. I would like you to think about what are 2 vocabulary words you know you're going to write down today. Proxies. Thanks, Emily. Proxies are one vocabulary word you're for sure going to write down today. Why don't you go ahead and write it down right now so you're ready? How do you think you spell proxy? Beautiful. Write it down and leave yourself some room to answer about it later. We know for sure that's something we're going to talk about today. Does anyone remember the second thing I mentioned?
Climate.
So climate for sure. That wasn't the one I was saying we should focus on though. Isotope. Oh man, how are we spelling isotope? I-S-O-T-O-P-E. Isotope. Beautiful. Alright. So hopefully you have those words written down. Isotope and proxy. We're going to talk about those a lot. Are you guys ready?
Yeah.
Alright. Paleoclimate. So I mentioned this before. It's climate evidence from the past. And the reason Army is on this slide is one, to make you laugh a little bit, because Mr. Danielson made this and he thought that was funny. But also because climate proxies tell us about climates from like way back when the dinosaurs were around. So when we talked about how old weather records aren't going to give us the information we need, because we're looking at climates from before people, okay? There was no people to write down the climate, so we need other ways to learn about it. So we're talking about old before people, like during the dinosaurs. Does that make sense? Okay. So modern human weather records are only around for the last few hundred years. So we can put fancy instruments like the one up here for these polar bears, and we can temperature, how much moisture is in the air. We can measure that directly today. But before people were around, we don't have any of these records, so we need different ways to learn about it. We also have some information from even before we had fancy scientific instruments, and even before we had people actually writing down what the weather was like. We have evidence of what the weather was like from even further back, because many indigenous cultures have stories that talk about big climatic events. Like maybe a tsunami happened and they have a story about it that they've passed down from generation to generation. And so we have more information about climate that goes a little further back because of this tradition, but even those are limited. They don't go back past before people were around, because, you know, there was no people to tell a story. You're not going to have a story to tell. So that is why we need to study environmental evidence to tell us about past climate. So all the things you're going to hear about today are environmental evidence, like stuff out of nature, and they're all called proxies. So proxies are these environmental evidence from the past. And a word that you're going to want to write down is indirect. Proxies are indirect evidence. So environmental evidence, indirect evidence is called proxy evidence. So let me give you two examples of how we can know about the climate. One way we can know about the climate is directly. I could walk outside with the thermometer and tell you that it is 72 degrees and it is not raining. And then you would have some information about the weather. And after we look at that information about the weather year after year, then we have some information about the climate. And we can measure that directly. But before people were around, and before thermometers were around, we don't have a direct way to measure. We don't have thermometer readings of the temperature. So we have to study environmental evidence. We need to look at things that indirectly tell us about the climate. And the first example of proxy evidence is fossil pollen. So fossil pollen can indirectly tell us about the climate. Remember how we talked about how certain trees grow in certain types of, certain temperatures and certain amounts of rain? So when we look at this fossil pollen, and we find from this tree, what kind of climate does this tree seem to be growing in? Hot and dry. I agree. Why did you say hot and dry?
Very dry.
Yeah, there's grasses. That's an indication that this is a place that gets dry. It's really sunny right now. And this is the pollen that we keep talking about. Michelle was asking me today about some pollen that we were seeing on our way to the assembly. Maybe you've noticed. They look like little tiny cotton balls floating through the air. So there's cottonwood trees are starting to pollinate right now, and you'll see little cotton balls flying through the air. And that pollen can tell us about the climate. So one thing that's important about pollen is that it looks different. So depending on what tree it comes from, we can actually look at it and see what kind of climate was this from, what kind of tree did this come from, and then we'll know about the temperature and the precipitation. So we talked about this before, but for example, if we found pollen that looked like this, we would know it came from pine trees. Angel, what do you know about pine trees? They grow in the cold. So if I find pollen that looks like this that comes from a pine tree, then I know something about the climate. What do I know? That it was cold. This example appears from an oak tree. An oak tree is a tree that likes summer drought. That means it doesn't rain in the summer. So I would know something about the climate if I found that pollen. But you can't just look at pollen and know something about the climate. The reason is, if I just picked up pollen off the street outside and looked at it, it would only tell me about right now. And I need to know about older stuff. And that's why we go and collect the pollen out of lake sediment cores. So remember on our imaginary